EDX Core Pure, Matrices 2, Transformations and Invariants. Reflections in two dimensions. First we're going to consider the matrix multiplication 0, 1, 1, 0 multiplied by 3 minus 2. So 3 minus 2 is our object, and if we do the multiplication we get multiply the 0, 1 by the 3 minus 2, which gives us minus 2. Then we multiply the 1, 0 by the 3 minus 2, gives us 3, which is our image. So there's the image, minus 2, 3. So 0, 1, 1, 0 maps the point 3 minus 2 onto the image minus 2, 3. So there's the mapping. In general, 0, 1, 1, 0 represents a reflection in the line y equals x. So that's a reflection in the line y equals x. If we have a number of points to transform, we can adapt the previous method. So here we're multiplying 0, 1, 1, 0 by 0, 3, 3, 0, 0, 2. So there's my object. And if I do the multiplication, so multiplying 0, 1 by the first column will give me 0, then the second column is another 0, and the last column would be 2. Then multiplying the 1, 0 by the first column, 0, second column would give me 3, and the last column would give me 3. So that's the image. And if we plot those points on the diagram, we can see that the image is a reflection in the line y equals x. So here we've got 1, 0, 0 minus 1 times xy. So 1, 0 times xy is x. 0 minus 1 times xy is minus y. And we can see, looking at this, that the x-coordinate stay the same, but the y-coordinate has reversed its sign. So this is a reflection in the x-axis. If we look at this second case, if we multiply minus 1, 0 by xy, we get minus x, and if you multiply 0, 1 by xy we get y. So the y coordinate stayed the same and the x coordinate has been negated, so this one is a reflection in the y-axis. So here we've got 0, 1, 1, 0 times xy. So 0, 1 times xy gives me y. 1, 0 times xy gives me x. And you can see that x has become y, y has become x, and that implies the matrix has created a reflection in the line y equals x. And in this second case, 0 minus 1 times xy is minus y, minus 1, 0 times xy is minus x. So x has moved to minus y has moved to minus x, and that represents a reflection in the line y equals minus x. Quite a nice way of practicing this and working with this is if we look at the matrix 0, 1, 1, 0 first, it's called the left-hand rule. So if you use your left hand, and you can do this visually as we're going along, you use your left hand and your thumb represents 1, 0, so your thumb should be pointing along the x-axis. Your index finger represents 0, 1, so that's pointing along the y-axis. And the index finger is going to end up moving to the first column of this 2 by 2 matrix. So our thumb should end up pointing towards 0, 1, and our index finger 0, 1 will end up pointing towards the second column of the matrix, which is 1, 0. So our thumb will end up at 0, 1, which is the first column of the matrix. Our index finger is going to end up at 1, 0, which is the second column of the matrix. And that's what your hand should look like now. Your thumb pointing towards 0, 1, your index finger pointing to 1, 0. In other words, it's a reflection in the line y equals x. Nice little note here. If you can see the back of your hand after the transformation, then you know it is a rotation. If you can see the palm of your hand after the transformation, then you know it has been a reflection. And you can use that to work out simple transformations of various matrices. 1, 0, 0, 1 would represent a reflection in the y-axis of the line x equals 0. 0, 1, 1, 0 is a reflection in the line y equals x. And finally, 0, minus 1, minus 1, 0 is a reflection in the line y equals minus x. You can test those using the left-hand rule that we were just looking at. So you can investigate these simple transformations. You can try using the GeoGebra file to investigate the significance of what happens to the points 1, 0, 0, 1 and their images. And the link is there to the GeoGebra file. In the next session, we're going to be looking at rotations in 2D.